over 90% of AI projects never see the light of day. They never get deployed. And while there's a lot of excitement around these models, the reason why they're so difficult to actually deploy for real-world applications, particularly for critical domains like healthcare, is the fact that even though they yield very high accuracy, they're very hard to understand. It's very hard to know why a particular prediction is being made by a deep model. And this is an entire area of trustworthy AI and explainability that is being explored here. And that's important for many domains. So doctors are not going to trust a prediction unless they can understand exactly why that prediction is being made. A second problem is, which I referred to earlier, was the ingestion of domain knowledge. There are many applications for which you already have a lot of domain knowledge, such as you may know the system dynamics for an IoT application. You may know, let's say, you may have prior probabilities for a specific event occurring, or you may have just explicit symbolic domain knowledge about a particular application. How do you ingest this information into a neural network and combine it so that you effectively don't have to relearn this domain knowledge from scratch? You can actually utilize that. So that's a bit of an art right now, and there's no sort of standardized way of doing this. So that's a problem, and that's a challenge for deployment. And the third is that these models are extremely vulnerable to attacks, so adversarial attacks, and so you can these models tend to be overconfident, and you can sort of fool them into misclassifications or incorrect predictions with some sophisticated attack. Now that's worrying from a security perspective. And finally, there's the problem of calibration. These models give you a probability of how confident they are. And you only want to trust the model if it's giving you a very high confidence. But what if a model is very confident, but is actually wrong? So it gives you, with very high probability, it classifies a cat as a dog. Now that's going to be, catastrophic for a healthcare application. So a calibrated model will ideally reflect reality in its confidence metric. And so that's another area where neural networks deployment is meeting some sort of challenge, right? So work is being done across all of these areas right now to overcome these challenges. But of course, that's apart from the traditional challenge of actually providing these models with enough data, enough compute, being able to train these models with less data, being able to adapt these models in case of concept drift in the real world. So a host of challenges still remain.